First mistake students make when modeling curves in 9709 paper 3 is to linearize them incorrectly. I'm taking an example. Y squared is equal to a e to the power of kx, where a is a constant. Now, how do we linearize this? We log both sides. Apply a single log to each side. So log y squared is equal to log of the entire right hand side, a e to the power of kx. And here comes mistake 1. So log y squared can be written as 2 log y. And then this right hand side is written as kx log a e. This is wrong. The kx is the power only of e and not of a, and therefore the right way of writing this is to write 2 log y is equal to, we want to use the multiplication law here, so log a plus log e to the power of kx, and then in the next line you can make kx the multiplier for log e. Right, now we can just simplify it. We know that log e is equal to 1, and therefore it becomes 2 log y is equal to log a plus kx. Brings us to our second mistake, identifying the gradient and y-intercept incorrectly. So the equation that we have is 2 log y is equal to log a plus kx. What we need to do now is compare it to the standard straight line equation. Y is equal to mx plus c. Here m is the gradient and c is the y-intercept. Now the equation that we have involves a log y and an x. So we need to make it look kind of like the y is equal to mx plus c. So since the y is not alone, it is log y, we write it as log y is equal to log a plus kx, and taking the 2 over to the other side, it becomes a divisor. Right, now we're going to neaten this out further so that it makes sense to us. So log y, and we're going to split this up into 2 terms because the right hand side has an mx and a c. So we're going to write that as k by 2x plus log a by 2. So we've split it up, used 2 as the denominator in both cases, and written the x term first. So now this is looking more like our original straight line equation, which is y is equal to mx plus c. Now we can easily identify the gradient. So m in this case would be the coefficient of x, which is k by 2. And the y-intercept c is log a by 2. Third mistake students make is identifying the independent and dependent variables incorrectly. So you'll notice in our equation there is no y, there is a log y. So log y is equal to k by 2 x plus log a by 2. Now on your graph, since this is a straight line, I'm drawing the axes. If this is your straight line, we know that the intercept is log a by 2. We know the gradient is k by 2. But what goes on the x and the y axes? On the x-axis, it's just x. And on the y-axis, is it y? No. On the y-axis, it is log y. Why? Because it is y is equal to mx plus c. When we linearized the equation, instead of y, we have log y. And in the place of x, it's still x. So don't forget to correctly identify what goes on the y-axis and what goes on the x-axis. That brings us to the final mistake, substituting points incorrectly. Now, suppose we're given a point, I've marked it here on the graph. The coordinates of the point are 1.5 and 1.2. Now 1.5 represents the x value, but 1.2 doesn't represent the y value. It represents log y, right? So if you're substituting it into your equation, log y is equal to k by 2 x plus log a by 2. We won't be writing log 1.2. Now that would be wrong. Why? Because 1.2 is the value of the entire log. It's not the value of y. So what we should actually write is 1.2 is equal to k by 2. The x coordinate is 1.5 plus log a by 2. So you need to remember that the independent and dependent variables may not be x and y. They could also either or both be log of x and log of y. So be very careful when you're substituting. If they give you a graph with a point marked on it, check what's on the y-axis and what's on the x-axis and substitute it correctly. Check if it's a log y. If it's a log y, substitute that coordinate for the entire log y. If it's just y, substitute that coordinate for just y. That brings us to the end of this episode. We'll be covering more chapters in our series, Why You're Losing Marks, for 9709 paper 3. So don't miss any of it.